Recitation 6 about the rational functions. So the first one, we want to graph function f and the function g. And we want to find the domain of each one. And then we want to find the vertical asymptotes, if there are. And then we want to find the removable singularities, if there are. Sometimes it's called a removable discontinuity, or removable singularity means the same. And then in the end, we want to compare f and g to see how they are different. Okay, first things first, let's graph f of x. It's a linear function, right? So very easy to graph. It's a straight line. We need 2 points, or maybe at the most 3 points. So if x is 0, function value is 2. So we get, let's see, this is 1, 2, 1, 2. So let's mark. So x is 0, function value is 2, or y is 2. Let's look at this point. If function value is 0, x equals -2. So let's say -1, -2. So get this point. Now we can graph this line. Right? Oops, sorry. I'm using my finger to draw on the check marks. It's kind of difficult. Okay, so we got this straight line. That's x plus 2. What about this one? Well, for x plus 2, the domain is all real numbers. Right? Let's see this one. So g, the numerator is difference of 2 squares. So it can be factored as x minus 2 times x plus 2. Then the denominator is x minus 2. So in the numerator, we have factor x minus 2. In the denominator, we also have a factor of x minus 2. That becomes 1. Right? Because x minus 2 divides x minus 2. That's just 1. So now this is simplified to be x plus 2. And then this equals to f of x, isn't it? F of x. After the simplification. So f of x is x plus 2. But, so let's graph this. Let's graph the second one. Let me use a different color. Let me use green color. So, but the 2 is not in the domain, right? From the very beginning, this function. So this is 2. If x equals to 2 plus 2, that's 4. So let's see, this is 1, 2, 3, 4. So what do? We need to make an open circle here. Because 2 is not in the domain, right? The domain of G is x not equal to 2. If x equals to 2, it causes 0 in the denominator, which is illegal in mathematics. So the rest is the same. We still have this point. We still have this point. So let's graph this. So we have this open circle in the middle of this. Okay, so let's write down the domain for. So this is the graph of these two functions. So this is f. The first one is f, second one is g. The domain of the first one is all real numbers. It's from -infinity up to +infinity. This is a comma. Right. But the domain of G is a little bit different. It's from -infinity up to 2, right? The union starting from 2, but not including 2, up to +infinity. So their domains are different. The first one is all real numbers, but the second one, all real numbers but 2. So that's why we have an open circle here, right? Open circle here. So we call this 2, 4 removable singularity, right? Remember, in rational functions, the denominator, the factor in the denominator normally makes vertical asymptotes, right? But in this case, because those two simplified, so x minus 2 is no more factor. So the vertical asymptotes becomes a removable singularity or removable discontinuity. So that's the difference between those two functions. All right, the domains are different, the graphs are different. Let's see the second one. Let's see B. B will have a rational function. Oops. What happened?